Let's see how to add two signals. First we will see the case of discrete time signal. Let's say we have a signal x1 of n which is 1, 3, 2, minus 1, 5, 6, 1, and x2 of n which is equal to 5, minus 1, 2, 0, minus 1, 4, 7. The value of x1 of n at n equal to 0 is 2, and value of x2 of n at n equal to 0 is 5. For this signal the origin is 2, and for this signal the origin is 5. Now we will be adding these two signals, that is y of n equal to x1 of n plus x2 of n. So all we need to do is add the signal amplitudes at corresponding indices. What that means is, let's say we have to find y of 0. So it should be equal to x1 of 0 plus x2 of 0. Similarly, we can find y of 1 which is equal to x1 of 1 plus x2 of 1. So this is really simple. That means you just have to add the values at corresponding indices. Now here I have x1 of n and x2 of n here. From this, y of 0 has to be, this is x1 of 0 and this is x2 of 0. That is 5 plus 2, it should be 7. That means it is equal to 7. Now y of 1 is x1 of 1 plus x2 of 1. x1 of 1 is minus 1 and x2 of 1 is minus 1. So we will get minus 2. So the only thing we must note is that the indices should align properly. So let's do that first. I'll move this signal. Now all we need to do is add the values at corresponding indices. So y of n will be equal to 1, 3, 7. Here we have the origin. Minus 2, 7, 6, 0, 4, 7. We can also do this graphically. Before that, let's align these two signals here. I have replotted x1 of n, x2 of n and y of n so that they align perfectly. So here we have x1 of n, this is our x2 of n, and here we have y of n. Now at n equal to 0 its value is 2, at n equal to 0 x2 of n the value is 5, so at n equal to 0 the value of y of n should be 5 plus 2, that is 7. Similarly we can verify for other indices. Now let's see continuous time case. Now let's consider addition of continuous time signals. Here we have x1 of t, this is our x2 of t, and we have y of t which is the sum of x1 of t and x2 of t. So we can write y of t equal to x1 of t plus x2 of t. Now similar to discrete time case, all we have to do is add values at same instance. Let's see, between minus 2 and minus 1, the value of x1 of t is 1 and that of x2 of t is 0. So y of t, which is the sum of these two, it has to be 1. Now we need to repeat this for all instants of time. For simplicity, let's consider this instant here. Here its value is 2, here it is 5, and here it has to be 7. So if we can verify, so we will get 7. So we have to add the signals at all instances of time. Normally we don't have to manually sum up these signals, but it's good to know that when adding two continuous time signals, we have to add the values of the signals at each instance of time. I'll open Audacity, go to generate, I'll generate a tone, we'll generate a sine wave. We have different options here with frequency 1000 Hz and amplitude of 0.5, and I've selected the duration to be of 5 seconds long. Click OK. Now I have this 1 kHz waveform here. I'll go to generate, I'll generate another signal. This time I will choose square waveform and click OK. Now I have both square and sine wave. Now what I'll do is I will add these two tracks. So I'll select both the tracks. I'll go to tracks. I'll click mix and render into new track. What it does is it will basically add these two tracks and generate the third track. Now we can see the third signal which is the sum of the first and second track. So we have the third signal here. Now you may try it with waveforms of different frequency.